Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available to view at no charge. If you wish to view any of the other videos in this series, visit the AIPTD.org website. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation. Looking at how AI generates images. You type a sentence, and seconds later, an image appears that has never existed anywhere in the world. It feels like magic, but it's actually a clever, very learnable process, and the leading method is called diffusion. In this presentation, we'll open the hood on image generators and see exactly how they turn a string of words into a finished picture. It's almost magical. AI makes it possible to create a picture from a sentence. Here's a simple setup. You give the AI a prompt, like let's say, a red fox in a snowy forest, golden light, and out comes an image matching it. Type words, get a picture. That is truly remarkable. The result is so smooth, it's easy to assume the AI just found or photographed something real. But what's really happening is far stranger, and honestly, more interesting. Here's the surprising core idea. It all starts with pure noise. A diffusion model doesn't draw. Or start with a blank page and add detail. It begins with this, a screen of pure random static, like an old TV with no signal. Then, little by little, it reshapes that static a tiny bit at a time until a real picture appears. So it actually works backwards, from chaos toward order. So how on earth does it know which static to remove? Or how to reshape the noise? It's kind of like an old, untuned TV. That shows snow on the screen, but somewhere inside that snow, a picture is waiting to be created. So how did the AI learn to do that? The answer is rather simple. The model learned to do this in reverse during training. First, researchers took millions of real images and added noise to them, a little at a time, until each picture turned into complete static. This gave the model tons of examples, a clear image, and the messy, noisy version of it. Then came the hard part. The model was trained to undo each step, looking at a noisy image and predicting exactly what noise to remove to get back toward the real picture. Once it mastered that reverse technique, it could build an image from nothing but static. Let's look at the forward process in training. It moves from image to static. Now, let's look at the steps for destruction. First, it starts with a clean image, as you see on the left. Add a tiny bit of noise, barely noticeable. Then add a bit more, and even more, step by step until the picture completely degrades, as you can see on the far right. It's pure random static with no trace of the original. Crucially, each step adds only a small, predictable amount of noise. Let's look at the process of generation. We will flip it around. We will look at the process working from static to an actual image. This is the actual moment of creation. The model starts with pure static and runs the learned process backwards. At each step, it predicts the noise and removes a little of it, and the image gradually sharpens. The static becomes a faint shape, the shape becomes more detailed, and detail eventually becomes a finished picture. It's not painting an image, and it's not uncovering something that was hidden. It's gradually building a brand new image, one small step at a time, from nothing but random static. But wait, so where do the words fit in this process? If the AI model is just removing noise, the words are important. The prompt actually steers the denoising. It is the key. The user prompt is converted into a guide that the model consults at every single step. As it decides which noise to remove, at each denoising step it asks, does this look more like a red fox in a snowy forest? Each tiny denoising step is nudged toward your description. The words don't draw the image, they steer it. So generation isn't one big move. It involves many tiny steps. Generation is a loop, not a single stroke, a loop that is repeated many times. Step number 1 in the loop is to look at the current noise. Step number 2, predict what noise to remove, guided by your prompt. Step number 3, remove a little of it. In step number 4, we repeat this, often for dozens of steps. Each pass clears the picture a bit more. That's why image generation takes a few seconds rather than being instant. You're watching a quiet, rapid loop run to completion. Sometimes in image generation, things get weird. This same process we just described also explains the common glitches that occur. Hands and fingers often go wrong because the model captures the general look of a hand easily, but the exact count of fingers needs a precision it only approximates. Text inside images garbles for the same reason. Letters demand exactness. And sometimes you get strange or odd blends, because the model is recombining patterns it has seen, occasionally a little too freely. Once you understand how the image diffusion engine works, the applications and where it is used starts to make a lot of sense. And how this same engine also powers a fast-growing toolkit. The same diffusion process powers art and illustration, generating concepts in seconds. It drives design and quick mock-ups for products and ads. It's used in fashion for patterns and prototypes. And it's also used across games and film for backgrounds, textures, and assets. One underlying idea has opened up an enormous and fast-growing range of creative tools. Now it's time for our 3 key takeaways. Let's pull it together. Number 1, diffusion models start from random noise, not a blank canvas. Number 2, they were trained to reverse noise, so they generate by clearing static step by step. And number 3, your prompt steers that process, nudging every step toward the words you typed. It's remarkable. Noise in, picture out. Thank you for watching. Be sure to join me for the next video in the series, where we'll discuss the rise of multimodal AI. We will zoom out to the bigger picture, where text, images, audio, and video all come together in one system. As we explore the rise of multimodal AI, you can find that video and the rest of the series by visiting the AIPTD web address below, where you can access the entire AI for Everyone library.